Hi, everybody. Welcome back. We're going to work on actually developing a data frame or a tibble that includes all of our text data along with average sentiment scores for each of our data points. And of course, we're looking back at the MOOC data that Ryan Baker collected some years ago. So the first thing that I usually do here is I clear out all of my variables, and then we're going to call in tidyverse, ggplot, stringer, and tidytext. And stringer gives us access to regular expression. If you want to look at the sentiments that are available in tidytext, you can use this function, get sentiments, and then you can just say, hey, this is the sentiment that I want to get, which is NRC. And that's what we're going to start with. We'll work on AFIN next. And as you can see, when you call this in, you're going to get a tibble. That tibble has 14,000 words in it, and each of those words has a sentiment attached to it. So abacus has a sentiment of trust. Don't ask me why. But a word like abandon has a sentiment of fear. It's also negative, and it's also related to sadness. But then they also have an individual sentiment score for past tense abandon and for the noun abandonment. So you can see that this is how the sentiment is organized. But what we really want to do is we want to assign this sentiment to a data frame or to a variable in that case. And in this case, we're going to say, hey, I want get sentiments NRC, and I want to assign this to NRC data. And then when we look at NRC data, we do actually have a tibble, which is at 14,000 by rows by 2 columns. As I mentioned before, NRC is a problematic dictionary because it's just binary, and it doesn't provide levels of sentiments because everything is just a Boolean classification. It doesn't have really weighted strengths for how positive or negative words are, but we're still going to move forward with it because, this is an introductory to NLP course. So the first thing that we want to do then is we want to call in our corpus. These are the forum posts from the Baker MOOC. If you remember, this was under the CSV data frame final underscore MOOC underscore Baker underscore data. And we're going to use dplyr or tidyverse read underscore CSV. We're going to assign everything to a forum post. And we're going to use this unnest tokens. We're going to put everything by word into that text. Right. And when we do that, we are going to have a huge data frame that is going to look at every single word within the data that was collected by Ryan for the MOOC. And the easiest thing to do is once we have this data frame called forum posts, we can then match the words with the NRC data for each text. And that basically is saying, hey, I'm going to take NRC words and I'm going to say, hey, I want to take forum posts and I just want to use inner join. And I want to inner join it with the NRC data. And this is going to join the words within the MOOC data with the affective dictionary using that inner join. It's going to automatically join by word because each of these data frames is going to have a column called word. And it's always important within these joins, left join, inner joins, that you have columns that have exact same title so that the joining can take place. And then when we call NRC words, we can basically see that we have about 18,000 words within the entire text data that we're using that is based on the MOOC forum posts. So of all those forum post words, about 18,000 of them match to the sentiment that is attached to them. And I shouldn't say 18,000 of them. It might be fewer than that because, as you'll see, some words will have 3 or 4 different sentiments attached to them because that's how the NRC works. So if we look at our table now, we've got basically a number of words, and we go all the way down to sentiment as well. And so we can see that the word here is question, and that is a positive word. And then lines, which is related to fear, and obvious, which is positive, and obvious, which is also related to trust. So this word obvious was counted twice, at least here, once as positive and once related to trust. Okay, The next thing we want to do is we want to create a count by text for each group of words, because each forum post may have more than one positive, negative word, one word related to joy or fear or disgust. And so what we want to do here is we want to create this variable count data, and we want to look at the NRC words, and we want to group by our anonymized name, right? And these are the MOOC members who posted in the forum, and we want to group it by sentiment, and then we just want to get a simple count for that. And when we do that, we have a nice table now that is down to about 2,200 rows that has 3 columns. And you can see we have the anonymized name for the MOOC student, we have the sentiment, and the number of times that member used that sentiment. So member 1 had 6 words related to anger, 10 words related to anticipation, 5 words related to disgust, 14 words related to fear, 7 related to joy, 24 overall that were negative, 39 that were positive, and all the way down, right? And in this way, we can basically get a pretty good count by student, by sentiment, by their forum post. Okay. So then we obviously need to widen this out, because right now this is a long format and it's not very helpful for us. So we're going to have a new variable called count data wide, and we're going to take count data and we're going to ask it to pivot wider. And we're going to say, hey, we want names here from sentiment, right? Sorry, here. So anger, anticipation, disgust, fear, joy. And we want values from N. So these are the values here. An important thing here is that in NA, and NA actually means 0. Like there were 0 instances of surprise words. And so we want to replace is NA with a 0. So we're going to use a function called replace. We're going to say every single time you find an is NA, that's what the period means here, just replace it with 0. And then we're going to look at our count data. And now we have a usable data frame that basically says, hey, this is member 1. Right? And member 1 had 6 words related to anger, 10 words related to anticipation, all the way across, right? But we can see that in like member 104 didn't have nearly as many sentiment words, and that might just be because member 104 actually has fewer words, but you can see that there were no words related to anticipation or disgust or joy, right? But there are some positive and negative words overall. What this tells us immediately is that before we can move on to do any type of analyses, we really need to have variables that are normed by text length. Because if we just looked at these raw counts, we would automatically think that somebody like member 101 is going to have a lot more positive words than member 104. But it is possible that member 101 has 1,000 words that they use within the forum posts, and member 104 only had maybe 50 words or something. And so we need to get norm scores by member for each of their sentiment categorizations. So in order to do that, we are going to create another new data frame called number of words texts. We're going to read in this final MOOC Baker data. And we're going to mutate this. We're going to say, hey, we want to have a new variable called number of words. We're going to use something called string count, right? And we're just going to say, hey, I want you to do this by text, and I want you to count, and this is regular expression, the number of words you find, and nothing more than that. So we run that, we're going to get a new variable called string sorry, we're going to get a new data frame called NW underscore texts. We're going to look at the structure of that, and you can see that we have a number of words in there as well. So the next thing that we really need to do is we need to join basically the number of words by text with our content data wide, right? And then we need to do a little deep layer magic so that we can create basically normalized scores for each of these variables. So they're just not raw counts for the times that the words occur, but rather normalized by the number of words in the text. And this is going to be our final tibble for NRC. So we're going to say, hey, we're going to create a final tibble called final NRC forum tibble. We're going to take number of words and we're going to inner join it. And we're going to inner join it with count underscore data wide. And I'm going to put a by variable in here. And this just says, hey, I want you to join it by anonymized name. And then what I want to do is I want to create some new variables. So I want to create a mutate at, and I'm going to look at a variety of variables. I'm going to say, hey, I want to look at all the variables between anger and trust. And then I want to norm each of these variables by the number of words. And this is going to give me new variables that are normed by sentiment, right? And then the next thing that I want to do is, because we need to have kind of a variable that has either 1 or a 0 or a complete or incomplete that's attached to it. And you can see what's going to happen down here eventually is that we're going to have norm scores, and then we're going to have a completion string. All right. So right now, completion is either a 1 or a 0, but we want to give it an actual kind of factor name. And so that factor name is going to be called completion string. And we're going to use something called case when. And case when basically says, hey, if completion equals 1, I want you to change this or create a new variable called complete. And if completion equals 0, I want you to create a new variable called incomplete, right? And so now we're going to have a data frame that incorporates both the number of words by text and all of the count data wide. It's going to have normalized values for each of the sentiments, and it's going to have a new variable called completion string that is either a complete or incomplete. And when we call up the structure of this and we go down, we can see all of our old data was basically here. And this is all of our new data. So this is the anger and all the way through trust, but these are the raw counts, right? And then our super new data is going to be the normed counts. So this is basically normed counts, which are going to be trust divided by the number of words in this case. So we can see that we have 0, 0 here, meaning that there were 0 words before, but now we're going to have a normed count by the number of words for each of those members. And then we have this completion string, and that completion string is going to be incomplete, complete, complete, or incomplete. And that's going to help us when it comes to visualization, which is what we are going to do in just a moment.